Well,
more.
the show's all yours, man. Good, thank you.
Awesome. Well, good evening, everyone. Thanks for coming out. I will try not to keep you too long. I do tend to ramble a little bit, so do pressure me, shame me, whatever you need to do to get me to hurry up. Building AI agents with C#. Who here knows what agents are? Couple of hands. Not everyone. Okay, that's interesting. Okay, maybe I'm just too close to the Kool-Aid. Anyone play that drinking game when you were watching Build? Every time someone said agent, you took a shot? No, because you're all live. Oh, one person at the back. Well, you're Irish, so you know. That's fine. Can't believe I said that for the camera. Anyway, yeah. In this talk, what we're going to do is I'm going to not go too deep on agents. We're going to take it nice and like a gentle foot into the world of AI agents, particularly building them with C#. Because a lot of samples out there, a lot of examples are built in Python, a language I detest for a number of reasons. And the point is feature parity with, what happened to my voice there? Python and C# isn't quite there yet. So I'm just going to talk about these frameworks, talk about what agents are, why we build agents, what they're useful for, how we can build them using C#. So show you some examples. Hopefully they work. I'm connected to the internet, so the demo gods are on my side. And then if we have any questions, just feel free to shout out and ask. A little bit about me. I am a senior software engineer at Microsoft. I work in a team called the Industry Solutions Engineering Team. Basically, we code alongside customers to deliver great outcomes on Azure and building Microsoft technologies, which is a pretty awesome job. Previously, I was an Azure MVP focused on Kubernetes and open source, more open source than Kubernetes. I'm a former rugby player as well, and I'm a conference speaker and YouTuber. I have a YouTube channel. I haven't done any videos for a while, just because I've been busy. I'm planning a wedding for later this year, so I have no free time anymore, which is great. Not really. So yeah, like I said, we're gonna just touch a little bit what agents are, then we'll explore some agent frameworks. AutoGen is not up there. Who uses AutoGen? Knows about AutoGen? Fantastic. AutoGen is a framework, one hand. It's not a framework I've used in anger, so I'm not going to talk about it because I don't know a lot about it. And then we'll go through some demos. They will work. They'll be fantastic. You'll blow your mind. And then we'll have a little bit of a Q&A at the end. If you do have a question, just put your hand up and I'll come to you. Cool. So what are AI agents? So agents are essentially an agent in itself is essentially a software entity designed to perform tasks autonomously or semi-autonomously by taking input. So who here's used GitHub Copilot? Yeah, a few of you, when you're working with agent mode, you're essentially providing an input by chatting to it, saying, hey, do this for me. Here's my use case. You craft a prompt, and then it goes ahead, takes that input, processes some information, and then takes actions to achieve the goals, specific goals. Agents can send and receive messages, so generating responses using a combination of different models, different tools, human inputs, or any other customizable components. They're designed to work collaboratively, so they enable complex workflows by interacting with each other, and then you have frameworks that allows for the creation for very simple agents. So, hey, go and do this thing, go and retrieve some knowledge from this knowledge store, go and call this API, etc. Or you can have really sophisticated agent workflows and connected agents that kind of work together collaboratively to try and achieve an output. So when we talk about agents, the concept of agents itself existed well before large language models were a thing. We have like an agent that would run on a machine that does something. Essentially, the advantage of AI agents with using large language models is their ability to interpret human language that we provide it, and then essentially any environmental information as well to kind of achieve an output or to change the environment. And they could do this by performing actions, accessing tools. So you might think of an agent that has a tool that performs kind of sending an email function or calls a particular API to go and do something. And there's also knowledge as well. So it might interact with a database, a file system that's on your local machine, etc. And there are various different use cases and different types of agents as well. So we have like what we call simple reflex agents. So they're going to perform immediate actions based on some predefined rules, right up to multi-agent systems where you'll have multiple agents working within a system of agents. They all complete tasks independently, either cooperating with each other, or they're trying to compete with each other to achieve the best outcome, and then that outcome is presented back to you as the desired outcome as a user. So when should we use agents? So using an agent framework for application development, for example, provides us with advantages that are beneficial for certain types of applications. So when you think about traditional AI models and LLMs, they're often used as tools to perform specific tasks. Sorry, not LLMs, just generic AI models. So you might think of classification models, regression models, etc. Agents introduce a little bit more autonomy into our systems, a little bit more flexibility and interactivity. So with AI agents, you might use them to kind of try to solve open-ended problems as well. So when you're thinking about using GitHub Copilot Chat, for example, if you're thinking, okay, I want to design a system that does this, there may be numerous ways that you can, or methods to try and solve that problem. Agents can kind of help you along with that. There may be multiple steps in that process, so tasks, particularly complex tasks, may require numerous steps to try and achieve an outcome. Agents can have that ability to have multiple steps in a process as part of a workflow to try and achieve an outcome, and also improvement over time, so we can provide feedback to agents in order to achieve tasks a little bit more successfully with ongoing feedback from ourselves or the environment that it sits in. So let's take a look at some frameworks. So I'm going to focus on 3 tonight. There was a fantastic demo on Azure AI Foundry. Within Azure AI Foundry, you can build agents, so we'll look into that. There's also Semantic Kernel as well. And then obviously, because I work for Microsoft, I am going to talk to you about M365 agents and the Agents SDK. Has anyone used any of these frameworks before? You? Which? Semantic Kernel? Yeah. Semantic Kernel at the back also as well? Cool, awesome, fantastic. So I'll start with Semantic Kernel, which is handy because that was my next one of my slides. So the Semantic Kernel SDK allows us as developers to build agents and also integrate numerous AI services together. So Semantic Kernel really acts as a middleware, or it can have agent logic components that add different capabilities. So a good example might be, I was talking a little bit about tools and knowledge stores earlier. Semantic Kernel can act as the middleware and the orchestration layer to kind of connect those together. You can now attach those to agents. So traditionally it was just kind of like chat applications or like basic one-shot kind of tasks that you could use within Semantic Kernel. There's now an agent framework to facilitate that. So there's not too much that changes in the underlying SDK, which is really good. And with the Semantic Kernel as well, you can have multiple different agents as well working collaboratively within an entire application. So you can have some agents that sit in Azure AI, you can also have some that sit in AWS Bedrock, and they can work together collaboratively as part of an entire system, which is pretty cool. So the Azure AI Foundry agent service, so essentially Azure AI Foundry functions like a little bit like a modern factory. So essentially the idea is you'll have models where you can select from a catalog of large language models. So GPT 4.0, 4.0, GPT-4, 3.5, whatever LLM you want to use. You can customize your agents with fine tuning. You can do some distillation and use domain specific prompts using real world data. So you can connect to your knowledge stores, whether that's an Azure SQL database, Azure AI Search, or a knowledge store somewhere else. You can equip agents with tools to kind of access knowledge that's within your business or in the real world. You can use orchestration to kind of manage agent workflows. So you can have state updates, retries, logging all through an orchestration layer. There is observability in the Python world. It's a little bit more sophisticated than it is in the .NET world. There is work that's being done to try and make sure that those are equal, but essentially the idea is you can monitor how agents are making decisions through something like OpenTelemetry, so through logs, traces, and evaluations, and in Azure that would sit in something like Application Insights that allow you to observe what your agents are doing. Also, there's a trust layer to it as well, so you can kind of build these agents using familiar enterprise-grade security tools like Microsoft Entra, RBAC, encryption, all that good stuff. And yeah, essentially Azure AI Foundry allows you to kind of like build agents and also connected agents as well, which is what I will show you in a bit. And then finally, the M365 Agent SDK. So essentially, who here worked with the bot framework? It's a little old, no? One person at the back with a very exasperated sigh. If you dig into the SDK definition, so you go into Visual Studio, it's essentially very familiar, there you go, API. So essentially it is built on top of what we used to call the Microsoft Bot Framework. Essentially with the Agents SDK, you can build an agent quickly that kind of sits in a container, not a Docker container. It's just like a loose framework where you can attach state storage and essentially add like message handlers as activities to kind of register what your bot is going to do. A really good example, which I'll show you later, you might have, who here has built kind of low-code agents in Microsoft Copilot Studio or any low-code agents on any platform? One person at the back. So essentially in Microsoft Copilot Studio, you have the benefit of where your kind of pro code developers, people sitting in the room here today, and also your low code developers, so your domain knowledge experts might be like, okay, I want an agent to do this and use these knowledge stores and just click and drag and drop and all that horrible stuff that's just terrible from a DevOps perspective, but we won't go into that. Essentially with the Microsoft Copilot, you can kind of bring them together. So you might have an agent that you want to extend capabilities to. You'd use something like the M365 Agent SDK to go ahead and do that. And with the Agent SDK, you can actually connect to other different AI services as well, which is completely agnostic as well. So I can attach Semantic Kernel services to agents that are deployed to Microsoft Copilot. I could talk to GCP, I could talk to AWS or whatever I want. And that could be deployed to Microsoft Copilot Studio. So you have that ability to use the SDK to talk to agents with different AI services in different spots. So it's not restricted to a specific tech stack. And yeah, it's kind of pick your poison. So essentially Copilot Studio is really designed for kind of your citizen developers or your low-code developers, but they can work collaboratively alongside your pro-code developers with something like using the M365 Agents SDK. And there's also options for Azure AI Foundry and Semantic Kernel. You can use them collaboratively, well together. So you can deploy agents that have the Semantic Kernel features. You can deploy that to Azure AI Foundry, and then you can connect agents that are deployed to Azure AI Foundry to Copilot Studio. It's not quite as clean as we showed at Build, taking off the Microsoft hat for a second. There is still some integration that you have to do yourselves. The example I will show you is that I've got a proxy agent that's sitting on APIM, and then I'm using a custom connector SDK to essentially do some routing between different agents. But it's possible, it's feasible. All right, so let's go into some code and see how this actually works. So I've still got the internet, which is good. And now what I want to do, I'm going to start off with the Semantic Kernel demo. So hopefully, there we go. Oh God, this work device is challenging. There we go. Okay, is dark mode good for everyone? Fantastic. If I just go in a couple of times, if I go in like that, is that going to be can people at the back see? Awesome, fantastic. Cool. So let's start with the semantic kernel. So this example, I've got 3 text files, and essentially I'm going to use this agent to ask some questions about these documents. So this is really agentic RAG, or a very basic agentic RAG kind of pattern here. So make sure I'll get out of multiple connected agents. I will go into Semantic Kernel. Come on. I'm making the taps loud enough so you guys know that I'm hitting it. You know what would be great if I was actually in the right directory. There you go. So I'm in Azure AI Foundry. Now I'm in Semantic Kernel. There you go. And now I'll go into file search, and essentially what I'm going to do is I'm just going to go ahead and run this. And what should happen here, so I've just got this very basic console application. So I'm taking in those 3 file names, which are just neatly sitting in my directory. And then from here, I'm instantiating my client. So I'm using an Azure OpenAI client. So I've got a LLM that's been deployed to Azure AI Foundry that I'm doing using this. I'm opening up an AI file client and also a vector store. So I'm vectorizing these documents. That's going to go ahead and upload, and now it's ready. So what I want to do, I've got this basic agent that's defined here, this OpenAI assistant. So Semantic Kernel supports various different types of agents, which all have their own kind of SDKs or their clients, I should say. So I'll just quickly go into CS Proj. So as you can see there, so there's a specific package for it. So semantic kernel.agents.openai. You might have one for Azure agents, AWS, Bedrock agents, etc. There are various different NuGet packages. So it supports different types of agents. So you can imagine as part of your kind of like greater orchestration flow, you might be working with multiple different clouds with agents that are deployed to different locations. Semantic Kernel helps allow you to bring all of those into kind of one place and work with them together. So essentially what this OpenAI agent is going to do, it's just an assistant agent. So essentially the document store contains text of fictional stories, analyze the document store to provide an answer to our questions. Never rely on your knowledge of stories that is not included in the document store. So very simple instructions. Have I made it bigger? If I go, there we go. I'll tell you what, if I get rid of this, get some real estate going. There we go. Is that a bit better? More?
If you're narrating it, it's fine.
If I go more. All right. Okay, so let's go ahead and ask some questions. So what's the moral of these stories? Because there are 3 stories. So now, hopefully, what we should see is the LLM, what it's doing is providing me the moral of the stories and also providing me the sources of the documents themselves. So it's saying, okay, here's my answer to your question, and then also from the knowledge store, here are my sources. So that's gone ahead and done that. So we can also ask, and yeah, then it's actually printed out the sources for me. So this is a very simple like agentic RAG kind of pattern where it goes, okay, here are your documents. Here's kind of what I want you to do, and I've asked them to just keep your answers limited to the documents that I've provided you. Don't go outside, and go ahead and just answer my questions. So I could ask how many paragraphs are there in the documents? Really benign question, but hopefully that should give me some numerical answers as well. So yeah, very simple kind of agent breakdown. Oh, I analyze the specific character. Okay, so there we go. The beauties of LLM. So unpredictable answers, fantastic. That didn't do what I really wanted to do. But yeah, you essentially get the idea. So there's nothing really too left field here. I just want to make sure I've covered all my bases. So yeah, so I've created a vector store. They're all various different clients. This is all happening locally, so you can have vector clients that are sitting in something like Cosmos DB or Azure AI Search. Too many products with AI in them, which is great, by the way, for the recording. defining my agent there, and then I'm going ahead and creating that agent, and then starting the conversation thread, which is pretty neat. Awesome. I will move on to, which one shall I move on to? I will move on to Azure AI Foundry. There we go. So this is a bit of a different example. So there's an idea, or sorry, there's a pattern where we kind of connect agents together. So we have an idea, if you think about our business domain, and who's done a little bit of microservices development, where you'll have like domains where you want to split them up, but they all kind of interact with each other, and then people are like, well, it wasn't this fine as a monolith? Anyway, let's not get into that argument today. The idea of multiple connected agents kind of sitting together is that you'll have within a domain space entities that need to work together, but they belong within a specific domain space. So when I talk about connected agents, that's essentially what I mean. So it's nothing too sophisticated going on here. So within actually I'll just show you the CS profile. So there's a package where we have azure.ai.agents.persistent. And within that package, we can go ahead and actually create agents that we deploy to Azure AI Foundry. So this example here, again, I've got using the same model that's sitting inside Azure AI Foundry. I'm creating a persistent agents client, and then I'm going to create my connected agent. So I've got one agent that's going to fetch me a stock price for a company, and I'm providing it with some simple instructions. So if I ask for Microsoft stock price, always return 350. It's a little higher than that, which is good. And then also another agent that goes and retrieves the weather for me. And if I ask for weather in Seattle, always return 60 degrees and cloudy. That's not the point. So those two are kind of sub-agents. The idea behind this is that those agents have now become tools within our larger parent agent. So you might have, coming from a semantic kernel world, you might have a tool that retrieves something from a particular API. It's conceptually the same thing, but now rather than just a simple tool, it's an agent that's part of a multiple agent system. So once those two are defined as tools, we can then go ahead and create our kind of larger agent, which I'm named my assistant. And then within the instructions, I say use connected agents to go ahead and get stock prices and weather. And then I'm registering those agents as tools to my parent agent. And then I'm going ahead and creating a thread. Within that thread, we're going to persist a message. So we're going to ask what the stock price of Microsoft is and also the weather in Melbourne, just to mix it up and see that. And then we'll go ahead and run our agent. So actually what I'm going to do, I'll switch from Visual Studio Code to Visual Studio. And I will zoom in because I haven't set up. There we go. I haven't set up like debugging properly on Visual Studio Code, and it's a lot more simple. And what I'll also do as well, I will also open up Azure AI, Azure Foundry for you. Actually, what I'll do is I'll keep that to one side and we'll just run through this. So go ahead and start this up. So all I'm doing here is just using kind of the iOptions pattern a little bit here, not too strictly, to try and inject some settings. And then I'm going to go ahead and create my agent. Hopefully that's going to be okay and I don't have to log in again. Hopefully those two sub-agents should be created, which it has. Fantastic. We'll just continue. And then we're going to go ahead and use those sub-agents and then define them as tools using that connected tool definition instance. Let's go ahead and continue that. And then that's been added to the main agent there. So hopefully in Azure AI Foundry, let me go ahead and refresh. Cool. So now we can see our agents have been created here. So if I actually go down into my assistant here, I can see that you're a helpful assistant. The systems instructions that I defined in my code have now appeared in Azure AI Foundry. And then also the tool, LLM that I'm using, and there are my connected agents as well. So there's my stock price bot, which I've got here, and also my weather bot as well, or weather agent, I should have named that. But you can see that that through code, I've been able to connect those agents together. So let's go ahead, and I'm just going to go ahead and run that. And I've kept the console output here because I want to see what kind of crazy response it reveals and make sure it's, safe for human consumption. Also be great if it works. Okay, cool, there we go. So there, from the output, we can see that, okay, what's the stock price of Microsoft and the weather in Melbourne? So again, it's gone to its default value that I've defined in my system instructions for the Microsoft stock. However, I don't have the latest weather information in Melbourne. If you've ever kind of played around with this and used GPT 4.1, it's always, there's a cutoff date, so it's not going to be able to get the latest information. So I recommend checking a reliable weather website or app. Fantastic. Just a small part of the planet that we burnt down to get that response. No, I'm joking. Yeah, so anyway, the point is those two agents have kind of worked together to produce a response back to our original prompt. Just go ahead and clean it up. Before I do, let me just go back into there, make sure I'm not missing anything. Yeah, one of the things that is coming, so in the Python world, there is kind of a neat integration with open telemetry packages and the Azure AI Inference SDKs from the Python side. Where you can actually go ahead into, where's tracing? There it is. As you can see, it's in preview, and then you would see like a nice output of how many tokens your agents are consuming, how evaluators work, etc. But unfortunately, in the .NET world, it's not quite there yet. So, yeah, which is a little unfortunate. I'm just going to do some cleanup there. That's going to go ahead and delete my agents. There we go, fantastic. So that's how it works from an Azure AI Foundry perspective. And now finally, what I'm going to do is take you through the M365 Agent SDK. So I won't be running this locally. So what I'm actually going to do, I'm going to show you how this works using Copilot Studio. So this is Microsoft Copilot Studio, and I've got a whole bunch of agents that I've got here. So if I go into my principal agent, so with agents in Microsoft Copilot Studio, you have kind of two types of agents. So you've got generative awk or gen awk agents, which essentially use generative AI to come up with a response, or NLU-based agents, which will have defined paths. Has anyone here played around with Lewis? Like the old Lewis, L-U-I-S. I see a smirk at the back. That's a yes from you, Akansha. No? Okay, so essentially, it was a very, what was it? Language Understanding Intelligence Services? Yeah, there you go. That's what it was. I have no idea what it actually stands for. I know language understanding was part of it, but essentially you would define kind of entities and what we now call as tools and expressions. So if someone like answered it or asked a chatbot a question, it would pick out the entities, do some entity recognition, and then have kind of predetermined paths of how to actually answer that question. With Copilot Studio, you now have this generative AI orchestration to kind of determine how best to respond to users and events. So this principal agent can, using the M365 SDK, we can actually, there's no direct connection, sorry, I'll take a step back. There's no direct connection between Gen Awk agents and NLU-based agents. So you can't just magically connect them up and say, okay, you two talk to each other. We have to use a proxy currently for them to communicate with each other. And we do that by defining tools. So again, I've got this tool here called Weather Agent, which is using a custom connector. So if I go into that, essentially what I'm doing here, I've got this agent that's deployed to app service, and it's going to go ahead and get the weather forecast for me. I've got this connector which uses behind the scenes like an app registration to handle authentication. So if I go here and say, what's the weather like? The output might be a bit generic, but hopefully what we should see here in this plan, so I can see this weather agent has been connected from this principal agent. Weather information is being processed. Please hold for a moment. Fantastic. Anyway, try to ignore the output, but essentially what's happened here is I've got this base URL that's kind of sitting on some compute there. So I've got an agent that's deployed to app service in this instance. It could be container apps. It could be whatever kind of compute that you want to host an agent on. And it's done some routing through this custom connector. So from a code perspective, what that kind of looks like is this. So I'll actually go through the program CS file first. So again, it's just like a normal web application or ASP.NET application that you build with, build normally for ASP web APIs or web apps. Essentially, this acts as a wrapper around Copilot Studio, enabled to do that communication from your generative awk agents into your NLU-based agents, or for any agents to try and communicate with an agent that's deployed to Copilot Studio. And we can add variety of different services to it. So you could have persistent storage. I'm using memory storage here, but if you have agents that need to handle state, you can use state from Cosmos DB, storage, etc. And also for some file transcripts as well. We can do some application options. And then this is our wrapper. So we have a Copilot client, which is essentially an HTTP client that's kind of wrapping around our Copilot Studio. We can do some authentication, and then from the bot itself, we're just attaching message handlers to it. So here, when we for our constructor, we've got our connection to our Copilot client, and then whenever someone asks our principal agent a question, essentially it's going to take the context from that activity and then act as a pass-through to downstream activities. Some of the neat stuff that comes with the M365 SDK, I'm going to go ahead and just create a new project, if I can handle my mouse properly. This is excruciating. No. There we go. What's nice about the M365 SDK agent toolkit, you can use the toolkits for both Visual Studio Code and Visual Studio. I'll just just keep it as that because the name's not important. But essentially, you can bootstrap kind of these applications. So here, using this custom engine agent, that's going to build a .NET 9 or provide a scaffolded version of .NET 9 application that I can use to build agents using the M365 SDK. So once that's created, I can see not only my application code that I showed earlier, but also some basic bicep that kind of scaffolds a basic, some compute for you that you can actually deploy to Azure and deploy this bot to. There was also, has anyone worked with dev tunnels? Dev tunnels in the past? Okay, it was a little bit painful trying to get this to do kind of local development. But hopefully with this, I'm just going to go ahead and press start. There is an agent's playground, which just essentially spins up a local emulator for you. So it's less painful and less, less challenging to talk to security saying, hey, I want to expose my local port to the World Wide Web. Now that it spins up a local emulator for you and you're good. Hopefully it does that. And if it doesn't, well, then something had to fail in this demo. But essentially that just starts something on a local host, which you then, rather than having to kind of connect that to kind of bot framework emulators, if anyone's had to work with that in the past as well, which is also quite painful, this kind of spins up for you. Yes, I will allow that. And there you go. I haven't got anything hooked up from an LLM perspective, so that's not going to do anything. Let's break something. Hello. Maybe it's just an echo bot that will just echo that back to me. There you go. Yeah, so there you go. Cannot connect to your app. Your app's not running because we haven't got connected to any kind of Azure OpenAI LLM, which is, but there's your playground to kind of build that, and then you could deploy that to channels like Teams or your own custom channels, like something that's sitting on app service. Awesome. So that's pretty much it for the demo. I will leave you with this one slide. This is, if I just go ahead and play that. No, wrong slide. There we go. So that URL there, aka.ms AI Agents Beginners, it is Python based. I do apologize for that. But that will go through what AI agents are. It will talk about design patterns as well and different types of agents as well. It also talks about running agents in production. From a .NET perspective, it's not quite there yet compared to the Python world. That's just the way it is. Work is being done to kind of improve that a little bit. But it'll talk about telemetry at much deeper length, also security as well, those important questions that, you know, as developers working in the real world, we have to answer. One kind of neat thing that I will actually show you as well, so some of the connected things, so rather than just having this kind of sitting on some compute as well, what I can do, I'll go into tools, I'll choose a different tool, so I'll choose this one and go into kind of the code view. That's sitting on, I apologize if I can, let me just try and do that as well. So yeah, so we can do that kind of relative paths magic to kind of deploy our compute to a gateway like Azure API management. So rather than, you know, just deploying our app somewhere, we can put something like APIM on the top of that and then have rate limiting, all that good stuff that APIM provides, and use that through custom connectors to talk to downstream agents. So it's not quite as neat as going into agents and then clicking connected agents and then just hooking it up to Azure AI Foundry instance or, you know, whatever. It's not quite there yet. It is coming. I don't have timelines for you. I'm sorry. I forget that disclaimer now. I'm on the other side of the bridge. But yeah, that is another way that we can actually kind of have that kind of connected agents pattern through tools as well. Cool. I'll just go back to slides. Come on, Will. And then I will give you that. Yeah, so hopefully that QR code is still valid. All my socials on there. My YouTube channel is on there. I will put the code that I showed tonight on GitHub, and I will share it on the meetup page. Sorry, I ran out of time to do that. It's very bad from a presenter perspective. Thank you all for spending your evenings with me. I really do appreciate it. I hope you got something out of it. And if you have any questions, let's hear them. Cheers.